Welcome to Frost and Sullivan's Growth Podcast. This series brings together key insights from our research, growth analyses, and thought leadership, highlighting the strategic imperatives shaping industries, technologies, and innovation ecosystems. In this episode, we explore self-powered sensors and batteryless Internet of Things deployments, examining how energy harvesting, ultra-low power electronics, and autonomous sensing architectures are enabling maintenance-free IoT ecosystems.
Batteryless sensing is redefining IoT deployments. The rapid expansion of Internet of Things ecosystems is increasing demand for sensing solutions that operate continuously without conventional batteries. Self-powered sensors are emerging as a foundational technology for next-generation IoT deployments. Energy harvesting technologies, such as triboelectric and piezoelectric nanogenerators, convert ambient energy into usable electrical power, enabling autonomous sensing devices. These systems support deployment in remote environments, miniaturized devices, and hard-to-access locations. Integration with ultra-low power electronics and wireless communication is further expanding adoption across healthcare monitoring, diagnostics, and distributed sensing ecosystems. As batteryless sensing becomes viable, IoT deployments are shifting toward autonomous and maintenance-free architectures. How is your organization preparing for batteryless IoT deployments powered by self-sustaining sensors?
Strategic imperatives driving self-powered sensor adoption. Several strategic imperatives are accelerating self-powered sensing technologies. Disruptive technologies are eliminating dependence on finite batteries and enabling fully autonomous IoT deployments. These sensors operate in hazardous, remote, and ultra-miniaturized environments where battery replacement is impractical. Transformative megatrends such as climate resilience, precision healthcare, and sustainability goals are increasing demand for continuous sensing. Batteryless architectures also align with circular economy initiatives and carbon reduction targets. Industry convergence between materials science, microelectronics, and artificial intelligence is enabling new energy harvesting sensor architectures. These cross-disciplinary innovations are creating new value chains across flexible electronics, biomedical devices, and smart infrastructure. Which strategic imperatives are accelerating your shift toward autonomous sensing architectures?
Growth drivers, accelerating batteryless IoT. Several growth drivers are expanding adoption of self-powered sensors. Demand for continuous health monitoring is increasing as chronic disease prevalence rises and home-based monitoring becomes more common. Self-powered sensors enable vital monitoring, wearable diagnostics, and implantable devices without battery replacement. Battery-free IoT deployments are also reducing maintenance costs across smart homes, healthcare, and industrial sensing environments. Autonomous nodes can operate continuously without manual intervention. Advancements in energy harvesting materials and hybrid architectures are improving power density and device miniaturization. These improvements are enabling scalable deployment across biomedical and wearable applications. Which operational priorities are driving adoption of batteryless sensing across your IoT ecosystem?
Challenges shaping self-powered sensor commercialization. Despite strong momentum, several challenges continue to influence adoption. Limited power density remains a constraint, as energy harvesting performance can vary based on environmental conditions. This restricts deployment in high-power applications. Development complexity is also increasing. Multidisciplinary requirements across materials science, electronics, and biocompatibility raise development costs and slow commercialization. Clinical and regulatory timelines further influence deployment in biomedical applications. Implantable and wearable devices must meet strict validation and approval requirements before large-scale adoption. Addressing these challenges will be critical to scaling batteryless IoT architectures. How is your organization addressing power, development, and regulatory challenges in self-powered sensing?
Growth opportunity spotlight, autonomous and biological intelligence. Three major growth opportunities are emerging in self-powered sensor ecosystems. Adaptive intelligence is enabling autonomous IoT sensor nodes capable of local processing and scalable deployment across industrial and healthcare environments. Biological intelligence is expanding opportunities for self-powered wearable and implantable devices. These systems support continuous physiological monitoring and predictive health insights. Longevity-focused architectures combining self-powered sensors with self-healing materials are enabling long lifetime monitoring systems. These technologies support autonomous repair, energy regulation, and sustained sensing performance. Together, these innovations are enabling scalable, maintenance-free, and sustainable IoT deployments. Where will self-powered sensors create the strongest growth opportunities in your IoT strategy?
That's all for this episode of Frost & Sullivan's Growth Podcast. For deeper analysis, research insights, and strategic frameworks shaping future growth, explore our studies and resources at frost.com or reach out to our team at hello@frost.com. We'll be back soon with more perspectives to help you stay clear-headed and growth-ready.